Okay, so the first thing we'll take a look at is back to a little bit of equation reviewing. So I'm going to move fairly briskly since I'm going to assume at this point most of you are comfortable here. So this triangle should be real familiar by now. Pi over 4 is the reference angle, and since it's a negative ratio, the sign is going to be down in these two quadrants. So this will be 7 pi over 4, and this will be 5 pi over 4, which makes D the answer. Okay. In the next example, it's really tempting for people to divide stuff out and just go, okay, this is like sine, and sine x equals cos x. But the problem is you've lost information if you do that. So you can move the ratios anywhere you want, but don't eliminate them out of your equation or you'll lose some of the possible answers. So if I did this, you'd see I'd end up with probably 2 answers. The real solution is actually going to have 4. So if you canceled out sine, you would have been tricked into picking one of these two here, which are wrong. Okay, so let me just show you what I mean. Instead of dividing out the sign, what we're going to do is we're going to move it over and factor. So if I factored out a sine of x, then I would have sine of x times sine x minus cos x. So where does sine x equal 0? Well, I think we're unit circle people here. So that would be there and there, which is at 0 and pi. If you're a person that likes looking at the graph, then those are the spots right there and right there, which again is the same thing, 0 and pi. Okay, the other one, which is a little bit trickier, is asking you where does sine x minus cos x equal to 0? So in other words, where does sine x equal cos x? So there's a couple ways you can think about it, but I think the easiest one is to still obey that rule of don't cancel out, but move around. Can anyone think of a creative way to move this? Right, remember I said normally we don't work with trig equations with more than one ratio. Did anybody get an answer for this? No. Oh, yeah, Helen?
Oh, you just move the cos x over to sine x, and then tan x equals to what?
Yeah, that's a good strategy. I'm not actually removing the cosine. I'm just moving. So it's not disappearing. It's just being moved to the other side. So there, that actually says tan x equals to 1. So if tangent x equals 1, and again, all the information's there, it's just now it says tangent instead of sine over cosine, then that's the triangle that looks like this. 1, 1, root 2, and pi over 4 is the reference. If it's going to equal 1, I'm in quadrants 1 and 3. So that means I'm at pi over 4 here, and at 5 pi over 4 here. So I would be, looks like D is the answer. Okay, so again, it's legitimate to use identities or move anything around that you like. Just don't take things out of the equation or you'll lose information. Oops. Okay, so for the next one, this was in your homework booklet. Some of you may recognize this. So I brought it back up again in case it's a tricky one. Anytime people put letters into a question, it tends to freak them out. So basically what you always want to do is say, if there were letters, if instead of letters there were numbers here, I could actually do these questions. So you want to proceed like they were numbers. So for example, if these were numbers, this is probably what most of you would do is you'd say, I need to figure out where that equals to 0. And then you'd say, I need to figure out this, which means, oh, look at that. Now there are numbers in there. So that one's simplified nicely, but if I was to try and solve this, to think about the graph, where does it equal -1? Well, there's only one spot from 0 to 2 pi, so there's one solution for that first equation. Okay. So you'd proceed the same way with the second equation. They're letters, they're not numbers, but how would we solve it if they were numbers? Well, most of you would be saying, I got to find out where this equals to 0, so I'm looking for where the cosine of x is equal to c divided by b. And at this point, you freak out and you probably either look at see what your neighbors got on their paper, or you just skip it altogether, right? But the thing is, we haven't looked at one extra piece of information here. Okay. It says b is less than c. So that information is important, because if I wanted to think what kind of fractions is it they're asking me about, it's abstract. They're giving me letters. So sometimes it's very helpful to say, let's put a face to this abstract number, this c over b. So for example, here's one possibility. It could be like 5 over 4. B is less than c. It could be like 100 over 2. Any number where the top is larger than the bottom. Okay? So if you think about the graph, here's cosine. It's bounded by 1 and negative 1. What can you tell me about the fractions that are going to come out of c divided by b? Nothing? Sorry? It has to be greater than 1. So in order for that fraction to work, whatever number I put on top is going to be larger than the bottom. It's always larger than 1, which means it's always going to be up here. It's never going to touch the graph. There will be no solutions from that equation because it never touches where the graph is. So it would be A. There's one solution. Oops. Okay. Pardon me? There's only one solution, yeah. Question? Yeah, any number we put in, like it could be 1,000,000 divided by 999,000, it's still going to be a number larger than 1. There's no place on the cosine graph that's larger than 1, so there is no solution. Okay. The next one, actually I think the next couple, they're graphing calculator questions. And somebody stole my graphing calculator. Okay, so I prefer the zero method, so I would write this down as y1 equals tan x minus cos x plus 2. And then I would use the zero method to find it. So if I was to do that, tan x minus cos x plus 2, a good window is going to have 0 to 2 pi will show up on my window. And a good scale will be something I can see. So something like 1 or a half will be easy to count. And I need to see the x-axis in order for this to work. So make sure the x-axis is visible. So in my graph, I get a picture that looks, let me just sketch it. It looks kind of like this. Let's see, there's sort of like this one kind of curve that way, and another curve that goes that way. Okay? And if I use the zero method on this one, let's just see here. It's going to be, it looks like B is the answer according to my graphing calculator. Okay. The other thing, of course, I can see that there's 2 solutions in this picture. So just by looking at my graphing calculator, I could eliminate these choices and say there's 4 solutions in there. My picture shows 2. Problem? Uh-oh. And if I count off, the tick marks, this one here, it's like just before the tick mark for 2. And if I keep counting, it's like here's 5, and here's 5.5 on my graph. So I could see from the picture without using the zero method that there is in fact 2 answers and that it should be B. In the next one, I would have gone y1 equals 2 sine x minus cosine 3x in order to use the zero method. And again, in this situation, let's see here, 2 sine of x minus cosine 3x. I can see in my picture, which looks a little bit like this, it kind of goes like that. Oops, 1 second. Did I write this in right? Minus cosine 3x. Sorry, it's different than that. It actually looks more like this. It goes up here, down, like that. So I can see there's two answers, so it definitely isn't these ones. And I believe if we were to, let me see here, 1, 2, 3, and a bit. So that makes it, I believe it's A. Okay, and then finally, in this example here, I would have y1 equal to 3 sine x minus 1. Yep. Just a second. All right. And that's the graph that looks like this. Kind of goes. And I can see, I believe my solutions are going to be 0.54 and 1.87, so it should have been D. Okay, for number 7, determine the general solution. What we're going to do here is we're going to say let theta equal 2x. There's no bounds, so I don't have to worry about polishing up the bounds. I can keep them where they were. That gives me a new equation which says sine theta must equal to 1. And that's one that we can solve either using the unit circle here, or we can use the graph where it equals 1 right here. Okay, so in either case, we're going to get theta equals pi over 2. And if we wanted the general solution for theta, we'd add 2 pi n, because that's the period of this graph. But the problem is we weren't asked to solve for theta, we were asked to solve for x. So in this case, we're going to say x equals half of theta. So in that case, that means x will be equal to half of what I had here, pi over 4. The period of the sine graph that I was given, this one has a period of pi. So that means I'm going to be adding pi n, where n is an integer. So it should have been B.